Hey guys, we're going to start looking at number 6 here. It says, what would a sine or cosine function look like for a part A vertical reflection and part B horizontal reflection? All right, so obviously I didn't leave very much space here. I'm going to draw a sine parent function. All right, it starts at 0, 0. There's like one cycle right there. And then here's my cosine function, parent function, starting at 0, 1, and there's one cycle right there. All right, so a vertical reflection, I'll put these vertical reflections in purple. Vertically, for sine, instead of starting at 0, 0 and then going up from there, it will reflect and go down. So here's my vertical reflection. It still hits 0, 0, and it hits all of my x-intercepts actually at the same point. And then it would do the same thing again. It can actually go on the other side of the y-axis. It would always just do that same cycle over and over. Cosine, same deal. My vertical reflection, instead of hitting at +1 on the y-axis, it's actually going to hit down at -1. And then it will go through wherever it hit the x-axis, the same points. Still bouncing between +1 and -1. So there's my vertical reflection. My horizontal reflection, horizontally, like left and right, I am going to have it reflect on the other side of the y-axis, but really this does continue forever on both sides. So the green one is actually going to end up giving me the same as purple one. So like my vertical and horizontal reflections for sine end up with the same graph. Cosine, if I do a vertical reflection, it actually, on the other side of my y-axis there's one cycle, but if it continues doing the same cycle over and over, it actually gives me the same as my regular cosine graph. All right, so there's both the vertical and horizontal reflections. And then we're going to look at the period of sine and cosine. The period is how long it takes before it starts to repeat. Usually it is 2 pi on your parent function. We're going to treat it as 2 pi over b for any of the sine and cosine functions. The b, though, let's figure out where the b came from. Here's our transformations that we can use here, and the b was what was multiplied by the x. All right, so that's where we're going to get the b to plug into this period of sine and cosine. In this case, the b is 1/2. I have like a 1/2 x. So b is a half, which means the period is 2 pi over b, 2 pi over 1/2 in this case. So I'm going to end up with a period of 4 pi. So it should take a distance of 4 pi for this cycle to, for this to end one cycle. All right, it is my sine function. So I do know that it starts at 0, 0. I haven't done any shifting or, a reflection. I haven't done any of that. I just know that it's going to take all the way until 4 pi to finish one cycle. Okay, so one of my key points is 0, 0. If it takes 4 pi, let's see, we've been counting by pi halves, right? Pi halves and then pi, 3 pi halves, 2 pi, 5 pi halves, 3 pi, 7 pi halves, and then here is the 4 pi. So it's going to take all the way until this x value to get to one cycle. And sine is going to end that cycle at 0, so that would also hit the point 4 pi 0. And then again, sine in the middle of this one cycle, in the middle it should also hit 0. So in the middle of 4 pi would be a 2 pi. So we're going to have the point 2 pi 0. And then sine, usually it should go up, hit its max, go through the x-axis, hit its min, and back to the x-axis. So let's look at what the max and min are. My amplitude here, it's like a 1 sine of x over 2. My amplitude is a 1. So the highest that it's going to hit is actually at 1 and -1. Maybe I'll do that as a 1/2. and a 1. I'll go negative 1/2, negative 1. But right between these x-intercepts, so between 0 and 2 pi, I should hit my maximum. Between 0 and 2 pi is 1 pi, or just plain pi. So I'm going to hit the point pi 1. Okay, there's my max. And then between this x-intercept at 2 pi and the x-intercept at 4 pi, between those guys, right in the middle is 3 pi, and that should be my minimum, so that'll go down to a negative 1. So 0.3 pi, negative 1. All right, so here is our graph, one cycle, for this sine of x over 2. And then it would keep going, doing the same thing over and over again. All right, and then there are some other transformations that we could do. There's a horizontal translation, like you can shift the entire graph left and right. You've got a vertical translation. You can shift it vertically up or down. And so this has quite a bit going on here. Let's see if we can figure out the horizontal translation first. So I need the bx plus c, and I'm just going to write the parent function here. The way we did a d plus the a cosine of bx plus c. Okay, so this was my parent function for cosine. And it looks like my a is the negative 3. Looks like b is a 2 pi and c is a 4 pi. I don't have a d. I've got nothing added or subtracted outside of this cosine function. So next up, I am going to try to figure out what these transformations are. Let's start with the period. Let's do that. That's kind of what we did up here. The period was 2 pi over the b, and we know that our b is 2 pi, which what that means in this case is the period 2 pi over 2 pi is just 1. So the period in this case is 1. And then that's like how long it'll take to complete one cycle. Now, whether that period begins at this first distance of 1, or maybe it's kind of, in the middle here, we need to figure out where that period begins. So that's going to have to do with my horizontal translation. So let's look at this part right here. This will help me find, like, usually it starts at 0. One period starts at 0 and ends at 2 pi. Like this one up here started at 0, ended at 4 pi for one period. But I'm going to kind of solve these two equations to figure out where this period starts and ends. So my bx minus c is the 2 pi x plus 4 pi. All right, that's going to equal 0. And then I'm also going to have the, let's see if I can squeeze it in here, 2 pi x plus 4 pi. I'm going to have that equal a 2 pi. All right, so I'm doing both of these to figure out where this period is going to begin and end. So I will subtract 4 pi. And then I'm going to divide by 2 pi. All right, so I'm ending with a negative 2. Now, I'm thinking if it starts at negative 2 and I have a period of 1, it's probably going to end at a negative 1. Let's check this out. I'm going to, again, on this equation, subtract 4 pi. And I will divide by 2 pi again. So negative 2 pi divided by a positive 2 pi is a negative 1. Okay, so that kind of makes sense. I'm going to erase this here. So maybe I'll count this x-axis. Maybe I'll count it by like half or something. There's like negative 1/2. Here's my negative 1. Negative 3/2, negative 2. All right, so if it starts at negative 2, if it starts here, we're supposed to have a period of 1. So negative 2 plus 1 is negative 1. So it would start at negative 2 to end at negative 1, which that's what I found with the other equation as well. And actually it would keep repeating. Then it would, the next cycle would go again and end at 0, and then it would end at positive 1. We should have the same distance for each of these cycles. All right. So I know where I'm putting this. Let's figure out like what the cycle is going to look like. I do see that I have an amplitude here of, I should do the absolute value of the A. So my amplitude is actually 3. Okay, so key features here. I've got the period. My amplitude is the absolute value of -3, so +3. Okay, I'm going to need that. That means that it will be bouncing between, instead of like 1 and -1, I've got an amplitude of 3. It's going to bounce between +3 and -3. So I'm going to count my y-axis by 1. I know I did not count my x and y-axis by the same number. Okay, so I should have one cycle right here that should be bouncing between my -3 and +3. So it's got to be doing this kind of bouncing between those. I also noticed that I've got a negative in front of my 3, which that would have a vertical reflection. So usually cosine starts at its max. I'm going to do a vertical reflection. It'll probably start at its min. So let's check this out. We're going to get some key points here. Its minimum is at -3. So if I start this cycle at -3, I would be at the point -2, -3. All right, and the end of this cycle is supposed to go a distance of 1, so I would get that also ending at the same y value. So I'd get -1, -3 as well. All right, so -2, -3, -1, -3. All right, and then in the middle of those, I should hit my maximum, which the maximum highest y value is at +3. So I think I'm going to have at -3/2 x value, I hit the y value of +3. Okay. All right. And then as far as my x-intercepts go, my x-intercepts are not going to be all that pretty here. So here's your parent function. Let's look at that again. Okay. So here's your parent function. I'll get rid of these. The x-intercepts here were right in the middle of the max and min, or the minimum and maximum. I should have 2 x-intercepts. So let's figure out what is right in the middle of the max and min on this particular graph. So let's see, between -2 and -3/2, if I turn those into fourths, it's like a -8/4 and a -6/4. So right in the middle of that would be a -7/4. So I would get the point -7/4, 0. And then my -1 is like -4/4, and right in the middle of -4/4 and -6/4 would be -5/4. So -5/4, 0. All right, so right between these guys are where I hit my x-axis. There are my x-intercepts right there. All right, so it looks like it's a sharp V, but I'm going to make it a curve. At least I'm going to try and make it a curve. Good heavens. Okay. And then it would, repeat. It would go through at halfway through, hit the max, go down halfway through those, hit the min. So it would just keep going over and over and over again. All right, and then for number 9, this one actually does have something added up front here. This kind of has a D value that we didn't have on number 8. So this 2 is going to be a vertical shift. So this is what our D does right here. It'll shift either up or down depending on whether it's a positive or negative. This is a +2, so my D is greater than 0. It's a positive number. We will shift the entire graph up 2. All right, and then I also have this A. Clarify that was a D. I have an A is 3, I have a B is 2. I don't have a C though. There's nothing added or subtracted after the X. All right, so next up, let's see if we can find the period again. So the period is, in this case, 2 pi over the B value is a straight up 2 in this case. So I get a period of pi. All right, so there's kind of a key feature we're going to need on our graph. The shifting, like the stuff that I did here to find how far I shifted to the left and right, I actually, because I don't have a C in this case, I didn't shift to the left or right at all. So I am going to start on the y-axis like I did on the parent function. My amplitude has to do with the absolute value of A. In our case, the A is a positive 3, so the absolute value of positive 3 is still just a positive 3. All right, so I've got my period, I've got the amplitude. If the period is pi, let's see, I'm going to count by pi halves here, and then there's pi. You can keep it going. You can do 3 pi halves and 2 pi. It will continue. Even in the negative direction, it would still continue in the negative direction. All right, so I'm going to get some key points here. Because we shifted up by 2, instead of having my amplitude is 3. Usually I would say it's bouncing between 3 and negative 3, but I've got to shift these guys. Even my max and min have to get shifted up 2. So that 3 is now going to have a max at 5. The negative 3, the minimum, is going to be at negative 1. So I'm going to be kind of bouncing between a 5 and negative 1. All right, and then, where am I looking at this here? Looking at the parent function, which again is this guy right here. All right, so this is my sine's parent function, and sine should start in the middle of its graph on the y-axis. And so I'm going to take like this 0.00, and we shifted everything up to, I believe, so this will go up to a 0.02 on our graph down here. All right, so this should be kind of the middle. I should be like bouncing around that. So yeah, we were going to hit at 0.2 to begin with. Here's one of my key points. I also know that I should end this cycle, which the period is pi, so I will end this cycle at pi, also in the middle of my graph. So I've got the point pi 2. And then in the middle of those should also be in the middle of my graph. So pi halves, I hit 2 as well. All right. So then it usually starts and increases to the max, hits the middle of my graph, goes to the min, goes back to the middle of my graph. So I think it's going to look like this, which means my maximum is whatever's between 0 and pi halves. So the middle between 0 and a half is a fourth. So at pi fourths, we hit our maximum, which the maximum is all the way up at, where are we up at 5? Okay, so here's that point up here at 5. And then between my pi halves and my pi, so that would be like between 1/2 and 1, in the middle of that would be 3/4. So I'm going to call this 3 pi fourths. Hits my minimum, which we said the minimum would be at -1. So there we go. There's our minimum of -1. And I'm going to connect these for just one cycle. Okay, so there's just that one cycle, and then it would, repeat the same thing on, both sides. Oh my goodness, my drawing is terrible. You get the idea. It would just repeat the same thing on both sides. So that was just one cycle, one period. And then let's look at number 10 here, last one. Little word problem. So I plotted the points that they were talking about over here. It says that the table shows the depths in feet of water at the end of a dock every 2 hours from midnight to noon, where t equals 0 corresponds to midnight. All right, so I just kind of took their points that they gave us and I plotted them on a graph, which if I connect these, I can see it's looking like one of these trig functions here, bouncing back and forth. You can really go with either sine or cosine. I think I'm going to go with cosine just because cosine starts at its maximum. And I can see what the maximum is. Sine starts at a midpoint, and I can't really tell what exactly is in the middle, at least not yet. I'll figure it out. But as of right now, I can see what my max, my highest point is. So I think I'm going to go with cosine. All right, so it says use a trig function. It didn't even tell you. I just chose cosine. So I'm going to write the parent function, kind of what we did up here is this parent function. All right. All right. Good. Oh, let me adjust this parent function. I apologize. This was a bx minus c. So sorry for that. That's why I was comparing it to this bx minus c. So let's see. I need to figure out what if I'm making it into a trig function. I need to find these key pieces here. I need the a, b, c, d on my cosine function. So I think a is probably the easiest one. The a is my amplitude, which, let's see, I'm bouncing between my highest depth here was 11.3. So this guy was at a y value of 11.3. And then the lowest, it looks like the lowest one was down here at a y value of 0.1. So that was like this guy down here at a 0.1. All right, so my amplitude, my A, is going to be my max, like my highest point, minus the lowest point. So if I subtract it, it tells me like what this distance is, but the amplitude should go right down the middle. So I'm going to take whatever that is and I'm going to cut it in half. All right, so just gonna do, let's do 11.2 divided by 2, and I'm at a 5.6 here for the A. All right, A, check, I got that one. I think the D is probably the next easiest thing to find. The D was a vertical shift. Usually my parent function is bouncing around 0, it's bouncing around the x-axis here. So let me find what the middle of these guys is, and then that would have to be the middle, like it'd have to be my D, how far I shifted it up. So let's see, if the amplitude is 5.6, I can either do the 11.3 minus, like go down by 5.6, or I can take my 0.1 and add a 5.6. Either way, I should end up in the middle of this graph. So let's see, my 11.3 minus a 5.6 ended up at 5.7. Okay. Or if I did a 0.1 plus 5.6, also 5.7. So it's like almost 6 here, 5.7 is the middle of my graph. So that means the D is a 5.7. Okay, so I found the A, I've got the D. All right, B and C, these are all the horizontal stretch and shrink, horizontal shift. So what I've got to do for this is I'm going to use, let's use the period. I think, let's show you the formula again for that. So the period is 2 pi over b, which because the I kind of have a graph. I can look at my graph and figure out how long it takes to repeat one cycle. So I can get the period and then set it equal to 2 pi over b. All right, so on this graph here, let's see if I can get rid of this purple stuff here so I can see the graph. Okay, so it looks like on this graph, I can see my maximum and my minimum. It's hard to see like a full cycle. I don't think I got points like to finish this full cycle. Let's just see from max to min how long that takes. So that went from a time of 4 to a time of 10, so it took a total of 6. That's just like half of one cycle, all right? Cosine starts at its max, goes down to its min, but then it bounces, not usually, it always, it bounces back up to its max. So I kind of have the first half here. I would have to have another distance of 6 to get this full period here. So one full cycle would take a total of 12 to finish one's full cycle. Okay, so now that I know I've got a 12 for the period, I know that the period, in our case 12, equals 2 pi over b. So I'm going to solve for that b. I'm going to multiply the b to the other side and divide by 12, which if I reduce this, I get like pi 6. Okay, so I just found the b. All right, we've got everything except for the c. All right, let's look at the c. We had an equation on the ones we were doing up here. Bx minus c equals 0, which 0 is where the period was beginning. Anyway, so we are going to try to find our c off of this equation. Okay, so at the very least, I can tell that this got shifted to the right. So I'm thinking I'm probably going to have some positive c here. Let's see here. Oh, uh-oh. I'll have to deal with that in a bit. Okay. What was up to? Okay, I was doing the C. That's what we're looking at. All right, so just to clarify, I want to talk about this bx minus c. There is another way that I could write it. I could write it as a b and then x minus c over b. Like I could factor the b out. And the reason I would prefer to do this is because any horizontal shift of some kind, if I'm going horizontally, I have to do with the x's. And I want to know what is added or subtracted to the x, not the bx. I don't want to know what was added or subtracted to the entire bx. I want just the x. So if I factor the b out, this helps me tell what I'm adding or subtracting to just the plain old x. So my point in that is, it looks like I said here, my max is usually where I start my graph. My max is at 4 right here. So I'm going to treat this c over b like a 4. Like I shifted to the right by 4. I actually know what the b is already. The b was a pi 6. So I'm going to replace the b with pi 6. Okay, so if I multiply that pi 6 to the other side, I get 4 pi 6, or in other words, 2 pi thirds for my c. Okay, but that was me kind of rearranging the way that it was written in my equation. Those are totally equal to each other. I just thought strategically, this helps me tell what I was adding or subtracting to a plain x, not to a bx. Okay, so that means I actually have the a, b, c, and d now. So I can go ahead and put those into my equation. All right, so y equals the d, which we found, let's see, our d is 5.7. All right, plus a, our a was a 5.6. Oh, I might have to move this over a little bit. All right, times cosine of in parentheses here, the b, which was pi 6, times x, and then minus the c, which we found c was 2 pi thirds. So minus 2 pi thirds. Okay, so it says use a trig function to model the data. Okay, so here's our trig function that we came up with. And now we're going to use that trig function for part B, where you find the depths at 9 a.m. and 3 p.m. Okay, so 9 a.m. These are all, my x-axis are talking about my time in hours since midnight. So like 0 is right at midnight, 1 is like 1 a.m. We're talking 9 a.m. So it's going to be like right here, which if I'm connecting these, I think it's probably going to be what, between the 0 and 2. It looks like, here's my 2. It looks like it's between 0 and 2. So let's see if we get in that ballpark here. 9 a.m. is 9 hours since midnight. So I'm going to put the t value, or in our case, I put an x value of 9. All right, so at this point, I'm going to put this in my calculator. Now, please look at your calculator and figure out if you are in a mode of degrees or a mode of radians. So for me, my mode is in radians. Okay, so we're good. Like I'm talking 2 pi thirds, pi 6. I'm talking radians here. All right, so I'm going to do my 5.7 plus 5.6 cosine of, okay, here's my pi button, pi 6 times x, which in this case, I'm talking 9 a.m., so 9 hours since midnight, and then minus my 2 pi thirds. All right, so this was, again, the depths. I think they were talking about in feet. Yeah, you got depths in feet here. So we just figured out we had 0.85 feet. That was the depths at 9 a.m. All right. And then at 3 p.m., this is again hours since midnight. So if I went to noon, that's 12 hours. And then you got 3 more hours. I'm up to 15 hours since midnight. So I'm pretty much going to do this same thing here. I'm just subbing in, instead of a 9, I'm subbing in a 15. All right, so I'm going to go replace this 9 with a 15. Okay, so it looks like I got a 10.55, again, feet. That's the depths of the water in feet, 10.55 feet. All right, and then part C here, I'm actually going to cross this out because it requires that we either estimate off of our graphing calculator or we have to know inverse functions, which I haven't taught inverse functions, and I don't want us estimating off of the graphing calculator. I want to do stuff that we really know how to do, not estimate. Okay, so I crossed off C, which means that we are done with these notes. All right, I will see you guys next week. Have a good day.